Hey guys, welcome back. So today we're going to go over how do we drive our mechanical fuel pump with a Mazda BP 1.8 liter engine. So here's what we got. I'm currently running an ATI Super Dampener. It's actually from Flying Miata. Shout out to those guys. And if you look here in this picture, you'll see that there's these bolt holes, these three big bolts, this one, and this bottom one. If you were to install a supercharger pulley, you basically remove those three bolts and you can bolt in your supercharger pulley right here. So what I need to do is I need to build something that I can attach to this dampener and then install a crank drive to drive a pulley. Let me show you the pulley I'm talking about. Okay, so it looks like this. This is something I bought off of eBay, and it was actually pretty affordable, like 10 or 15 bucks a pulley. And it's basically a piece of steel hardened black oxide coating on it. And it's got these teeth. It's called a 5M HTD pattern. So it's like 15 millimeters wide, 5 millimeters spacing on the teeth. And these things are pretty strong. They're rated up to 20,000 RPMs. It has plenty of pull. You can actually transfer quite a few horsepower through that belt. And it's a tooth belt too, so they don't slip like a serpentine belt. So no problems there. But then we got to say, okay, how do we drive this pulley? Because this pulley has the inside diameter here is only a ½ inch bore. So that works on the pump because the pump has a ½ inch shaft. But what about the crankshaft part? That's the tough part. So if we go here, we can see this is eBay. Yeah, looking at $6 plus shipping. So yeah, like I said, pretty cheap. So, all right, here's our dampener. Now, what I need to do is I need to build a bracket, a mandrel, something that I can attach here, and it will present a ½ inch shaft that I can slide that pulley on. And let me show you how this has been going. I'm going to start off with this. So this is a company called Rapid Direct. I've used these guys, I don't know, a few times. They're actually great. Sometimes their pricing's okay. Sometimes, it depends. Sometimes they're the best. But they got a pretty good website. They're pretty quick. I've never had an issue with quality. They seem to hit their specs. So here's an example. I basically when I'm working on a project, I have to decide like, am I going to do it? Am I going to pay somebody to do it? Or is this even feasible? So the first thing I did was I went into my CAD modeling and I just modeled up a disc with a shaft pointing out and I put 3 holes in it. And I just took a guess because I didn't actually know these dimensions at the time. And if we look here, you can see the unit part price is $77. So it's actually not that bad. And this is making it out of a 4130 steel. So that's a real strong steel. You can use cheaper materials, but for this, I kind of do want it to be steel just for the durability. Anyway, so I looked at that and I was like, hey, that's not too bad. So what I did was I started changing the design, and let me just jump into CAD real quick and I'll show you what we came up with. This is after messing with it for a little bit. So here's the final one. So this black thing represents the ATI harmonic dampener. This is the adapter we built. I'm going to hide the dampener real quick just so we can get a good look at what the rest of this looks like. So here's our part. Now we notice we have bolts in here. So one thing I didn't mention already, but it's really convenient when you're modeling, is you can get the bolts. So this is a company called McMaster-Carr, and you can see here we buy this pack of bolts for like $6. You get 25 of them. But notice this bolt has that star head on it, or 12-point flange bolt. These are awesome because they don't strip. Like if you use an Allen wrench and you put a hex in there, man, those things are terrible about stripping. These things don't strip. They're super durable. So that's what I really like about them. And then of course here, if you look at the model, you get the dimensions for the length of the bolt, the height of the head of the bolt, and then the diameter of the bolt. So they have all that stuff there, and I can click a button here and just download a 3D file of it, which is incredibly convenient if you're trying to model something, see what's going to work. So here's our part. Let's go over some of the key features and why we ended up with this shape. All right, so the first thing that's obvious is we got 3 bolts. So I got the bolt circle. I actually posted on Miata Turbo, and I had a few posts. Somebody told me what the size was, and I also sent an email to ATI. They got back to me, so I knew what that was. So I drew 3 holes and said, okay, I got to have bolts that go through the holes that bolted up, and I know I needed to present a ½ inch shaft for the pulley to go on. Other than that, it's basically just connecting the dots and making it lightweight. Now, one thing you want to do is you want to center up this part to the pulley. So if we go back to the pulley real quick, here we go. See this bore on the inside? That diameter is exactly 1.9 inches. Exactly 1.900. I measured this on my car. And that's convenient because this part is concentric with the crankshaft. So what that means is if I go out here, let's go to the actual part. I will show you. Here's the part. If I were to roll this back enough, I don't know how far I'd have to go. Yeah, there we go. So you can see during the modeling, I actually made a circle there. See if I go back again. Nope, it's already gone. So I modeled it that way. But basically, this has that diameter, so that radius of 0.95, if you multiply that by 2, it's 1.9. So that shape will pick up on that bore and keep this part concentric. That way when it's rotating, it doesn't wobble. But as you note, I don't actually need all of it. So this backside part, see where here? I cut that out because that saves weight. I don't actually, once this outer edge has done the concentric, this is like the working face, right? That's doing the work. It needs a certain thickness so it doesn't just like fold over and break. But all that other material, I got rid of that because, weight. What are we going to do with that? Now, if we go to the front here, you'll see this shape. Now, where we looked at our assembly, you'll note the bolt heads and that metal. Look at that. There's a little bit of extra metal, but not too much, and that's obviously on purpose. We're trying to save weight. Now, once we did that, we said, hey, let's drill some holes in here to lightweight it too. And I might could have got more aggressive with this, but basically 3 holes worked out pretty good. I would have been getting a little too aggressive to do 4. And as you get towards the center, I made them smaller, which is a benefit because the torque load is higher and closer to here. So I wanted more meat here. So it gets thinner as you go to the outside. It gets thicker as you go to the inside. Now our shaft poking out, you'll see we put a nice generous radius. That's always a good idea. It makes these things stronger and less likely to crack on you. And then we also popped a hole through the center of it. And then, so now you can see we basically got 9 holes there, a big ass hole there. We put our radius, and then the last thing we did was we came in here and put another radius on the inside. And again, that's basically just to save weight. We don't really need that, but I knew it would save weight, and we're trying to save weight. So let me show you what this looks like from a cross-section view. So you can see here, as we get into there where we did the radius, yeah, there we go, there's a nice view. So we can see that we've still got plenty of meat in here. We didn't by putting this radius, we didn't make it so thin that now it's gonna like crack and break. You can see this is kind of like a really good sized radius. It's doing work. We got rid of some metal, but we didn't really like introduce a new weak link. So that's important. You wouldn't want to do that obviously. So let me hide that real quick and okay, got the cross section turned off. So that kind of goes over the basics of what we were thinking. Now, what we did when we were building this, you can imagine if you're a machine shop and you got to cut all these holes and do all this work, every time you add a feature, it probably adds cost, probably. But you got to work with what you got. And let me show you something. So I was tracking this as I did it. So we're going to jump into the website I was just showing y'all. And if you remember where we started off, we said we were at $77, right? I want you to check this out. So here's another version where I did this winged shape. So here it was just a circle, really, really simple. Here we've got these wings, and this was kind of a minimalist setup, but I wanted to see like how much more expensive, and it jumps up to 88. So that's only 10 bucks more. And considering all the weight we save, and it looks better if you ask me, I was like, oh yeah, that's worth it. So then we went to this design, we put a bunch of holes in it to try to save weight. And you can see our price jumped up again, but we only went from $88.50 to $90. It was like $2 to get all the lightweighting holes. I was like, oh, hell yeah. Now here, if you actually look at I'm going to click back and forth, notice the difference? This was doing that lightweighting cut to save weight on the backside. We cut away that material. Now that might seem like, oh, why would you do that? Well, look at the price. When the material was there, 90.3. When we removed it, 89.94. That makes no sense to me. Why would an extra machining operation be cheaper? But that's the reality. So, hey, it's a win-win situation. Here's the last one. If I click back and forth, you can see the difference. Those little tangs that poke in and do the centering, I made them beefier. And I probably could have got away with the thinner ones, but that was just something that I thought about it and I was like, man, let's not, that's okay. We just added a little bit. That doesn't really penalize us much. And we ended up at a smooth 90 bucks. Now that's for the part. These guys do kind of rip you off on shipping. I'm going to end up paying 50 bucks for shipping. So this is going to cost $140. But that's it. 140 bucks shipped to my door, machined, materials. But yeah, materials, machining, and shipping for 140 bucks. Kind of hard to argue with. Now, let me show you what's really cool. So we did all this work, and I say all this work, this took like 20, 30 minutes of goofing off. Let me show you what we got by doing all this work. I'm going to go to Properties, click on Physical, maybe. Here we go. 2.2 ounces. This thing weighs nothing. 2.2 ounces. So that's like what, an eighth of a pound. I mean, it's, incredibly light. And that's awesome. And you can kind of tell too, if I go back to this assembly and we put the dampener in perspective and you kind of zoom out, think of what a crank pulley looks like when you look down there. This little thing's tiny. And that's what we were going for. We're trying to save weight because not only is this weight that slows the car down, this is rotating weight on the crankshaft. So we don't want to add any weight here that we don't have to. The only caveat that I could possibly think of is I may need to extend this length a tiny bit. And I'm still thinking about that. I may go ahead and do that because that's something I could easily cut shorter if I needed to shorten it, but I can't really make it longer without remachining the part or doing something crazy. So what we may do is extend this slightly and then go ahead and place the order. And the reason is we're going to be waiting on these pulleys for a while. I've already purchased them. They look like this, but they're not going to be here till like the end of February or something. So I'm recording this in early January, so we gotta wait a while. So just to be safe, and I don't know the exact dimensions of the pulleys, and I'd rather not be wrong and have to wait and get this machine twice or do something like that. And of course, I guess if you look at it sideways, you can imagine there's a pulley with a belt. Well, these bolt heads are poking out. So the belt has to be sticking out in front of these bolts at least a little bit. That way the belt doesn't accidentally bump this. Like I said, the belt's only 15 millimeters wide. And then from here to here, that is 22 millimeters. So yeah, we are probably cutting that too close. So we'll probably extend this like a 1/4 inch or maybe a 1/2 inch at the absolute most. So that'll probably raise the price a little bit, but I doubt it'll be much, maybe a few bucks. And there we go. We'll have a part that weighs like 2.5 ounces, so basically nothing. It looks cool. When you see this on a car, that looks like a race car part. And I don't really have to FEA this because I maintained enough thick enough cross sections everywhere that there's nothing thin. You look at it from the front, we've got a 1/8 inch around all of this, and in the center it's even thicker. We did the cross section this way, and we could tell it was pretty thick all the way. This part's pretty beefy, so really no issues. And of course, we're using 4130, which is a high strength steel. So again, it's not just aluminum, it's not just 6061 aluminum, and it's not just steel. This is a high alloy steel. So this is pretty strong stuff. I don't remember the exact spec, but it's probably like 100,000 psi or something, whereas mild steel is like 36 or 40 or something. So very strong, shouldn't have any issues. Only a couple ounces, so pretty awesome. And we did this pretty efficiently. And the great thing is, I'll pay, say, 140 bucks, and this part's just going to show up at my doorstep and work. That's the beauty of it. Same thing with the bolts. We already know these bolts work. I contacted the manufacturer. They gave me the specs for the bolts. I found the bolts on McMaster. I just click a couple of buttons and they show up at my doorstep. So it's kind of easy. The only thing I have to do is grab a tool just to make sure I have a tool that fits the head of the bolt. But short of that, this is easy street. And this is a custom part. This is one of the custom things that I'm going to have to get done to put this mechanical fuel pump on a BP. So that's kind of nice. This part's actually not that bad. Now, unfortunately, doing the brackets for the mechanical fuel pump, I don't see an easy way to do that yet. That's probably going to suck. And we'll get to that, that'll probably be one of our next things. We actually needed to do this because I can't move the crankshaft. Like the crank, it is where it is. This pulley's where it's at. So I knew that I needed to model this up, make sure that I designed a mandrel that my pulley would fit on and the mandrel would fit to the dampener. That will tell me in an axial location where the pulley's going to be. So like if I was to look at this, say I extended this little piece a little bit, because I think we said we need to do that, right? So imagine we add a 1/2 inch to that. I'm just going to do the math over here to make it easy. So from this face to that face, it's about 1 inch. So let's just add a 1/2 inch and say 1.5 inches. So the center of the pulley, 1.5 inches minus, say, 1/2 inch is 1 inch. So let's just call it 1 inch from this face. This face is 3/16 from that, so 1 inch and 3/16. So I need the center of the pulley that's going to go on the fuel pump to be 1 inch and 3/16 away from the face of my ATI dampener. That's actually pretty easy now that I know that. When I go to work on the car and I start trying to mock up where the fuel pump's going to go, and it's going to have like an X and Y spatial dimension, but then it's also going to have an axial location. Now I know more or less what to target. And that was the point, because I don't want to wait until, say, the end of February to even start on that bracket. Even though that could happen, that's not what we want to do. So we are going to probably double check our numbers, add a little bit of length to this, and as long as the quote still comes back reasonable, we're going to get this sucker ordered and get it on the way. So anyway, hope y'all enjoyed that. This took about 15 minutes to film, but it only took about 30 minutes to do all the modeling. So it just kind of goes to show you that sometimes the stuff pays off. I'll spend 30 minutes and 150 bucks, and this part will just show up at my house and bolt up and work. So, hey, when opportunities like this exist, you got to take them. All right, guys. Hope y'all enjoyed this, and until next time, y'all take it easy.